Hello class, welcome to day 3 of Unit 2, Rational Functions. We're going to look at how we draw rational functions and what key features they have. So we have already talked about vertical asymptotes. It's looking at how things approach something up close in local behavior. To me, it is a brick wall. You cannot cross, and I call them VAs. Okay? If something is a vertical asymptote, that means it is a vertical line that the graph approaches and goes either infinity or negative infinity, depending what side you're coming from. So anytime you have a vertical asymptote, it is a missing value from the domain. Okay, so if you want to look at the notation, this limit notation, that means on the left or right side of a VA, the graph either goes to positive infinity or negative infinity. So if I had a graph that maybe had some VAs, maybe here's a VA, maybe here's a VA, and I'm going to draw this, and we'll talk about this in a second, but here's an HA. I cannot cross the VA, so maybe I would have something that looks like this. On the left side of this VA, it goes up to infinity. On this right side, it goes down to negative infinity, and on this left side, it goes up to infinity. On the right side, it goes down to negative infinity. We'll talk about horizontal asymptotes in a second, but on either side of this brick wall, to me, this is a brick wall. I can't cross it, but on the left side or the right side, it's going up forever or down forever. A horizontal asymptote is a little bit different. It just means the ends level off to y equals some number. And technically, you can cross in the middle. So if you look at this graph over here, you see how this left end is leveling off to some y value, and this right end is leveling off to some y value. But here in the middle, you can cross a horizontal asymptote. That doesn't really matter. So the whole limit behavior notation, it says either the right end or the left end is leveling off, to, in this case, to some b value. Okay, so I have some VAs, I have some HAs, I put some x-intercepts and some y-intercept dots on this graph, and now I have to play by the rules of the game. I cannot cross a VA. If I have an HA, the ends are leveling off, I must go through the dots. So over here, on this right side, I kind of have to be level, go through this dot, and I'm going to go down to negative infinity. On this right side, if I did this, that would be wrong because there's no dot I can go through it. There's no x-intercept, I cannot go through it. So this part is wrong. What I need to do is go like this. I can't have a blank part of the graph. The left side has to be level, and I'm going up to positive infinity. So what does the middle part look like? Well, the middle part, I must go through these two intercepts, negative infinity, x-intercept, y-intercept, up to positive infinity. The next graph here, well, there's no x-intercept, so I cannot go through the x-axis on this far right side of the graph. So I have to be something like this. And on the left side, I'm going to have basically the same idea. Okay, there are no x-intercepts on this part of the graph. I cannot go through the x-axis, or on this part of the graph, I can't go through the x-axis. But I have to be level. In this last part, maybe just I only could go through the x-axis when I have dots on the x. Maybe it's something like this. So my 5 key features that I put on any graph of a rational function. So a rational function is a polynomial in the numerator, a polynomial in the denominator, and I have these 5 key features of x-intercepts, vertical asymptotes, y-intercepts, horizontal asymptotes, and then this key feature at the end, a hole in the graph. Okay, so the x-intercepts is when y equals 0, or when the numerator is equal to 0. So when I have 0 divided by a number, this is a dot on the x-axis. A VA is when y is undefined, or, well, that's terrible. The denominator is equal to 0, or when I have a number over 0. A y-intercept never changes, rest of your life. Use x equals 0. And when I went to a horizontal asymptote, I just do leading term over leading term. I have 3 possibilities. Possibility number 1, y is just a number like 2 or negative a half, because I have the same degree in numerator and denominator. Option number 2 is y equals 0 when the denominator has a higher degree than the numerator. That means I'm always going to have some number over x to some power, and every graph of 1 over x or 1 over x squared is always going to level off to 0. And the last possibility is no HA, because the numerator has a higher degree than the denominator. Now finally, this hole in the graph, this key feature of a hole in the graph, is when I have both numerator and denominator are equal to 0. Okay, so we're getting the 0 over 0 business. Remember, we hate 0 over 0. It doesn't tell us anything. Okay, so everything has to be factored, and I'm getting the same factor numerator denominator. So when I have this fraction, I have some key features. First, I have x-intercepts on top. Second, I have VAs on the bottom. And finally, at the end, if I have a hole, it's because I have the same factor and they would cancel out to give me a 0 over 0. And when I want to find an HA, I do LT over LT, leading term over leading term. So even though, let's do an example. Even though it's feature number 5, I kind of look for it first. This is already factored, and there's nothing the same in numerator or denominator. They have to be identical to cancel out. So there is no hole in this graph. Feature number 1, x-intercepts come from the numerator. I get -2 and 4. Feature number 2, VAs, they come from the denominator, and that's going to be 3 and -4. Feature number 3 is a y-intercept. I'm going to plug in 0. Don't forget the -3 up front. So -3 times 2 times -4 over -3 times 4. and I get, let's see, 24 over negative 12, so I get negative 2. And then finally, my HA, well, leading term on top, if I multiply it out, would be negative 3x squared over x squared. I get negative 3 as my HA. So this looks very similar than the page before. I have a grid with some red dashed lines for the asymptotes and some solid dots. And let's see, on the right side, I have to go through this dot and level off to negative 3. So basically, I have to be something like this. On the left side, there is no x-intercept for me to cross. So I have to be below the horizontal asymptote and going down to negative infinity over here. And in the center part, I'm going to have to draw through these two intercepts, and I get something like that. Those are my features. So the next example, it isn't factored for you, so you have to factor it. I factored on the right. Nothing is identical in the numerator or denominator, so nothing cancels out, so there's no whole. Okay, now let's go through my features. X-intercepts on the top. On the top, I get negative 3 over 2 and positive 4. VAs on the bottom. I get negative 4 and positive 2. My y-intercept, I plug in 0, and I can plug it in the original. If I plug in the original, I get negative 12 over negative 8, which is 3 over 2, or 1.5, and then my HA, y equals, leading term on top is 2x squared, on the bottom is x squared, I get y equals 2. Okay, I drew my asymptotes in red, my intercepts in black, and on the left side, there's no x-intercept here, so I'm going to have to be above this horizontal asymptote and curling up towards positive infinity. On the right side, I do have a dot to go through, so I'm going to be below this asymptote, go through my x-intercept here, and go down to negative infinity. And in the center part, I have to go through these two dots. And remember, the horizontal asymptote doesn't mean anything in the middle part. You can cross it all you want. So negative infinity, dot, dot, to positive infinity. This is what this next graph looks like. Okay, this next example, I did factor it, and I see that there is something identical top and bottom right here. These two cancel out completely. The x value right here, so there is going to be a hole, and the x value right here is x equals negative 3. But what's left? The only thing I have left is this. Do not plug x equals negative 3 into the original or the one that's factored. You got to plug in what is left over after it cancels it out. I plug it in here, I get y equals negative 6 over negative 2, which is 3. So I have the point for the hole of negative 3 comma 3. That is, I have to put a hole here at negative 3 comma 3. Hole, negative 3 comma 3. Now I'm going to do my features. The x-intercepts come from the numerator. Well, the only thing left in the numerator is x equals 3. The denominator is the VAs, and my VA, the only thing left over in the denominator is x equals negative 1. My y-intercept, well, I plug in 0. I could plug in the original. I could get negative 9 over 3, which is negative 3. Or I could plug it in here, and I would get negative 3 over 1. I still get the same result. Doesn't really matter. And my HA is leading term over leading term, and I get 1. Okay, I plotted my VA and my HA, and in red I have my two intercepts in black, So on the right side of the graph, as you see over here, on the right side I have to be below and have to go through these dots. So I'll be something like this. Now on the right side of the graph, there's no x-intercepts to go through, so I know I have to be above this horizontal asymptote, but I also have this hole that I have to go through. So right through the hole, and something like that. And there's the graph. So now I'm going to go from graphs to equations. So when I write an equation, I'm really dealing with a lot of x's. So I need to know the x features. So the x-intercepts are important to me. And I have one here, and I have one here. And that is -2 and 3. And then I have VAs, because those are x values, and they're important to me. I have one at -1 and 1 and 2. So if I want to write the equation of this rational function, the x-intercepts are in the numerator. X plus 2 is a factor, x minus 3 is a factor, and in the bottom, x plus 1, x minus 2 is another, are the factors for the denominator, but I should pay attention to the HA. The HA is y equals 1. That means when I do leading term over leading term, I better get 1, and right now I have x squared over x squared, so I do have 1. That checks out. So this is the equation of that graph. So the question is, what if the HA was y equals 5 instead of y equals 1, as I did earlier? How could I modify this equation? Well, I don't have to do too much. All I have to do is put a 5 here. And now, when I do leading term over the leading term, I got 5x squared over x squared, which is equal to 5, and I get what I want. And then finally, what if there was a hole at this point? And all I really care about the hole is the x value. So right now, I have this. And now I want to put this hole in this equation. Well, here's my x value. So I have to do this on top and this on bottom. And these two is what creates the hole in the graph at x equals 1. I need to put in both the numerator and denominator. Okay, thank you for watching this video, and good luck with the classwork and the homework.